there's like the pandemic era albums, right? Like Evermore, like the two of them are very similar lyrically. Like the machine learning algorithm puts them together. The early albums all get put together because they are also very like thematically very similar. And then Reputation is one that really stands out as separate. Like Reputation is like quite distinct lyrically from these other kind of groups. So that was really fun to work on, and certainly like aligns with my own sort of, like how I perceive as a fan and and someone who enjoys um Taylor Swift's work. Like it really was an interesting way to explore something else that I love. I love doing data science projects about things that I love, and it really I just get a lot of joy from that.
Nice. Really cool to hear about that project as well. Another one that you did recently is with Stranger Things dialogue. And so for the popular Netflix series Stranger Things, you showcased high frex, Frex in all caps, high frex and lift words of each season's dialogue. What do those terms mean and what did you find?
Yeah. Okay. So topic modeling is a unsupervised machine learning method for analyzing text. Text data is very interesting. I mean, I guess no shock that I find it very interesting. But when you think about text and natural language, there are a couple of really defining things about it. You see a lot of power laws where there are a few words we use a ton, the and then there are a lot of words that are used only a few times. This means you count the things you're observing of in a very there's a really wide discrepancy in how many times you have counted things or observed things. And so you have to use methods that allow you to get at that, like allow you to learn something even giving that. There's sort of brute force methods where you just kind of like take out stop words, you make some cuts, but then there's much more sophisticated ways you can use to learn what words are important, what topics are about what. So a topic model is a multi-level hierarchical model, and the mental thing you can think about is that a topic is made out of a mixture of words, and words can be in more than one topic. And then a document is made of a mixture of topics. So with the Taylor Swift example, I think I did it so that songs or maybe lines, well, one or the other, songs or lines were the document. And then you say, okay, which topics, so which songs are made of which topics, and the topics are made of different words. So with stranger, so you end up with the most probable words, but those are often the same across a lot of topics. So in Stranger Things, I think I did it as lines, like lines of dialogue. And if you think about, like, if you have a group of people talking, the most common words are always just common words that people use speaking. It's different than the words if you were reading prose, so it's not so much the and, but more like you and like words you use as you talk. Like our spoken word is different than we do like written language. So dialogue, so those are the most probable words. But if you look at, the topics all have the same most probable words, but that's normal. That's normal and okay. And so these other metrics like lift and frex help you get at metrics of what words are special or unique for different topics. So they're different. They're like different statistics. Like frex is high frequency and exclusivity. So it means words that are used a lot, i.e., for high frequency, but also have high exclusivity, meaning you see them in some topics but not others. High lift is words that you see a lot relative to how often they are used. So if you had a word that was used a lot, but if you high lift for that word would have to be really high compared to something that was used only a few times. So one thing I remember from that Stranger Things is that like some of these high, if you're looking across the seasons, like what are these high frex, high lift words? Like you see the words about, that monster that they called Dart, the little funny monster that got lost in the house. Like that one pops up in that season because it's high lift, high frequency, high exclusivity. When they were there were things that only happened in the first season. Like they talked a lot more about like the upside down or something. And like those popped up in the early seasons because it was like high exclusivity to those. So their topic models are great. They are complicated models. And it is interesting thinking about when are they useful in the era of LLM based tools. And I think they are most useful when you have medium sized text data. By that, I mean like 5,000, 10,000. Like you have text data that many documents. So think of a document often in a real application is like a survey response or something along that line. So you have on the order of 5,000, 10,000, and you are interested in looking for like what are the topics, what are these about. You can, of course, look to LLM based tools for summarization, which can give you like another sort of way of doing it. But I tend to think they are most useful in situations either where you have compliance reasons that you can't use LLM based tools, or that you have more medium sized type data, or you have maybe you have needs for higher statistical rigor than like I threw it into an LLM and got something out. So I think even in the era of LLM based text tools, I think it never gets away the need for doing EDA for text, and that's exactly what the tidy text package is all about. Is about doing EDA for text. I would say it's a bad idea to just throw text you're analyzing into an LLM based tool for summarization without also doing EDA first. And it's also interesting to think about when would you use which kinds of tools, and like what are your needs. Like these are all tools. These are all tools, and adding more tools is great. But we have to know when it's appropriate to apply them.
Yeah, those are really great points you made there at the end around why you would use an LLM versus topic modeling, these kinds of more now what you might say are traditional
Yeah,
natural
yeah.
language processing techniques. And yeah, some great points there. If you want higher statistical rigor, if you want to be doing exploratory data analysis, which maybe you should be doing before you are
Yep, yep,
using an
yep.
LLM
No, I
anyway,
would argue yes.
mid-sized data, it's also probably going to be a lot less expensive.
Oh, absolutely. Absolutely. 100%. Because it is true. Like expensive LM based tools are expensive to use, either literally per API call or in the expertise of running a local one. Yeah, nope, that's absolutely true. Yep.